Dear students, so today we will talk about simulation. So what is a simulation? Simulation is the depiction of the real system. Before you construct a real system, you simulate it, you perform some experiment. So we can say in simple word, it's the approximate performance of the real system. So it is not the real system, but it is an approximation. You prepare something, for example, if you want to make an aeroplane, so first you simulate in a software, and then you see that what are the aerodynamics, and then you fly an aeroplane, right? So it will save the cost, it will save the energy, it will save the labor cost, right? and uh, and the time as well, right? So by this way, so there are different ways for, like, simulating things, and different variation of the formulas are there, but the most important basic formula is with respect to the probability. So what is the probability? As you all know that probability ranging from 0 to 1, right? So there in Excel there is a very cute function that is called rand. Okay, so we'll say that how it works. If you see, if you click on here, so equal sign rand and bracket, and then if I click on this one, it give me probability of 0.36, right? So next time if I again run it, it will give me another probability 0.95. If I again run it, so it will give me another probability. If I keep doing it, so the probability will change every time automatically. So it is just like when you play a ludo or you play a card, so you have a random number. Sometimes you have, like, 1 2 3 4 5 6 in a ludo, or you have, like, for example, head and tail. Sometimes you have a head and sometimes you have a tail, right? So this is also similarly, right? So now we're using this one with respect to like cost. So for example, if the cost is $43, let's suppose if the cost is your $43, right? And you have the cost, like for example $44. You have, like, here is the, like, suppose $44 cost, right? And here the cost of an item is $45, and here is the cost for, let's suppose, $46, and here is the cost as $47, right? So but the probability of this one is the 0.1, right? So you can say, even you can give some range, like from 0.1 to maybe 0.12, you can say, or you can say from 0.1 to 0.3, from 0.3 to 0.7. So the probability will be, like, in between this one. If you say, if you want probability from 0.7 to 0.9, so your probability will be ranging in this one. Okay, so the maximum would be 1 and the minimum is 0, right? So by this way, these are the different probabilities. And if you want to, like, perform some cost analysis over this, you say multiply by this one, right? So you got this one, right? So this is the multiplication of this one. And if you, like, if you want to perform for the rest of that one, you will have the different probabilities. You can see over here. So this is for the second one. You are simulating it, right? This is simulating, and you are simulating. So you're just multiplying it, and that is simulation. Now we have some variation of that one. Let's suppose we use the random number r, which is the random number basically. So random number is the probability which we discuss here, the rand cute function, right? So now r is here. Let's suppose we want to simulate that what would be the cost of a certain part of a car, let's suppose. Okay, so we say a is the smallest value of the part cost. For example, the smallest value would be, like, for example, $80 for any parts. Let's suppose the brakes of a car is $80, and the maximum would be, the genuine brakes would be $100, right? And but you simulated with a random number. So how we do it? The same formula: a plus r minus r multiply b minus a. So what is b? B is 100 and minus a is 80, and then you apply a rand function. Okay, and a is the smallest value over there, right? So with this variation we have it. So the approximate cost or simulated cost would be $84 at the first, right? And then you can have some different simulation. You can just, like, drag it, and you will have, like, a lot of values, right? So but it will be, the minimum would be 80. Why? Because here you say a plus. So when you say a plus, so it means the minimum would be 80, but the maximum would be 100, right? So maybe you see some close value which is related, which is equal to, I think this is the highest one, 93 is the maximum value you are getting it, right? So now by this way you are simulating with this one. Okay, now let's see some other, like, questions. Okay, now for example, if your data is normally distributed and if you have intervals, right? Okay, and then like if you want to see, like if you want to have, like, the inverse of that one random number. Okay, so for the inverse, what we have the formula, and you want to see the different rounds, 10th round, let's suppose. So there's a formula, normal inverse, right? The random number, comma, okay, the number you have it, for example, the mean value of your data, comma, standard deviation, right? So these three items you need it for the inverse of the normal distribution. So if you have this one, so you can just, like, drag and drop this one, and you will have the new values, right? Because it is changing. Why it is changing? Because of the rand function. Third most important thing is interval. So sometime, as I told you, you have the intervals. For example, for the sales of a month, for month 0, you have from 0 to 0.08, from 0.08 to 0.2, from 0.2 to 0.48, and the maximum, as I told you, it's like, the maximum is 1, and the minimum is 0, right? So this is, like, your full range, right? And let's suppose you have 24 units, like, so in case of 24 units, if you want to apply 24 multiplied by, let's suppose this one frequency. So the minute the this one is 0. So let's suppose let's simulate it, and you have the different, like, sales of the month with respect to. So for the 24 units, the sales would be according to this one, the lower probability. If you want to go for the higher probability, you can put, like, for example, say higher. Okay, higher probability is, for example, 0.08, 0.2, 0.48, 0.72, 0.86, 0.96, right? So these are higher one. Okay, so this is for lower, lower sales. This could be the lower sale, and the higher sale could be like this one, higher sales, because for higher sales you need a high probability, right? So I take the 24. Okay, so let's suppose 24 multiply by the higher value. So I'm sorry, no, not this one. Okay, take the first value. Okay, and then just drag and drop, because the yeah, now you see over here, so most of the values will be high. So this is, see, if you compare this is like lower one. Okay, so I highlight with the red color, and this is with the higher one, I highlight with the green color, right? So these are my higher sales, right? You can see over here, and that would be, so now you can compare it, the higher sale and the lower sale. Now now we have, let's, for example, completion time. So sometime you have, like, you complete your work or project in time, okay, and sometime it takes more weeks, sometime it takes less weeks. So if it takes more weeks, so that is a worst case, let's suppose. So this is like, it takes, like, 8 weeks, 7 weeks, 18 weeks, and 10 weeks. So the total is 43 weeks. So that is, like, worst case we have it. And this one is in the best case, if you have like 5 weeks, 3 weeks, 10 weeks, and 8 weeks, and you just accumulate it, and that is the 26 week is the lowest week to complete a project, right? And then service time. So for service time, you can have, like, the inverse of the normal distribution, and that is, you can, the same formula you can apply with the rand, comma 2 and 0.5, right? So this is about that. Okay, what if analysis, we have formula for profit, which is P minus CL minus CP multiplied by D minus CA, right? So what is the P? P is the selling price per unit, so which is, let's suppose, 249. Okay, and then we have, like, CA, which is, like, for example, 100 well, approximately 1 million, right? Okay, and direct labor cost, C is a labor cost, which is $45, and the demand is 15,000, right? So if you put in the same formula, okay, so and like, but be careful while multiplying, because if you just wrongly multiply it, and you must, like, apply the rule of, for example, first bracket, then multiplication, division, and then plus and minus, right? BEDMAS rule, you must apply that one. Okay, so and then we have another, for example, in Whatif analysis, another case could be, like, if you have the range of different dollars, for example, range for selling price is 43 to 47 for, let's suppose, shoes, and is for like as for example, another one is $80 to $100, and the units you want to sell is from 0 to 30,000 units. Okay, so for the worst case, what would be the profit and loss? Okay, if you see over here, if you apply the same formula, so the units, the 0 units we can sell it. So if you sell 0 units, so it means like, the worst case would be like this one, the profit is not there. For the best case, if you sell all the units, so like if you can see 43, if you put the $43 over there, okay, and minus $80, right? Okay, and so if you see, if you compute the formula accordingly, you can see over here you have 43 on the upper one and 80 on the lower one, right? And 249 is the cost already we had. Okay, so 249, if you remember, this is the 249 we got it from here, from the previous example, right? So this is the best case we have. Okay, now let's suppose we have like, parts of the cost, like, what is the part of the cost. So here we have this formula, and so which is equal to, like, for example, 80, and then the difference for 80 plus, and the difference of higher price, which is $100, and the lower price, which is $80, and then we multiply with the rand. Okay, if you want to simulate this one, you can also simulate it just by drag and drop, and it will give you a variety of the data. So I hope you understand the concepts of simulation, that how we can, like, estimate the real system with a simulation, and it will help you in a financial system. It will help you in a machinery system as well. So see you in the next video. Take care. Bye bye.